LongLoRA, efficient fine-tuning of long-context large language models. We present LongLoRA, an efficient fine-tuning approach that extends the context sizes of pre-trained large language models, LLMs, with limited computation cost. Typically, training LLMs with long context sizes is computationally expensive, requiring extensive training hours and GPU resources. For example, training on the context length of 8,192 needs 16x computational costs in self-attention layers as that of 2048. In this paper, we speed up the context extension of LLMs in two aspects. On the one hand, although dense global attention is needed during inference, fine-tuning the model can be effectively and efficiently done by sparse local attention. The proposed shift-short attention effectively enables context extension, leading to non-trivial computation saving with similar performance to fine-tuning with vanilla attention. Particularly, it can be implemented with only 2 lines of code in training, while being optional in inference. On the other hand, we revisit the parameter-efficient fine-tuning regime for context expansion. Notably, we find that LoRA for context extension works well under the premise of trainable embedding and normalization. LongLoRA demonstrates strong empirical results on various tasks on Llama 2 models, from 7B/13B to 70B. LongLoRA adopts Llama 2.7B from 4K context to 100K, or Llama 270B to 32K on a single 8xA100 machine. LongLoRA extends models' context while retaining their original architectures and is compatible with most existing techniques, like flash attention 2. In addition, to make LongLoRA practical, we collect a dataset, LongQA, for supervised fine-tuning. It contains more than 3K long context question-answer pairs. RMT, Retentive Networks Meet Vision Transformers. Transformer first appears in the field of natural language processing and is later migrated to the computer vision domain, where it demonstrates excellent performance in vision tasks. However, recently, Retentive Network (RetNet) has emerged as an architecture with the potential to replace Transformer, attracting widespread attention in the NLP community. Therefore, we raise the question of whether transferring RetNet's idea to vision can also bring outstanding performance to vision tasks. To address this, we combine RetNet and Transformer to propose RMT. Inspired by RetNet, RMT introduces explicit decay into the vision backbone, bringing prior knowledge related to spatial distances to the vision model. This distance-related spatial prior allows for explicit control of the range of tokens that each token can attend to. Additionally, to reduce the computational cost of global modeling, we decompose this modeling process along the 2 coordinate axes of the image. Abundant experiments have demonstrated that our RMT exhibits exceptional performance across various computer vision tasks. For example, RMT achieves 84.1%, top 1 ACC on ImageNet 1K using merely 4.5 GFLOPs. To the best of our knowledge, among all models, RMT achieves the highest top 1 ACC when models are of similar size and trained with the same strategy. Moreover, RMT significantly outperforms existing vision backbones in downstream tasks such as object detection, instance segmentation, and semantic segmentation. Our work is still in progress. LLM-Chat-1, M, a large-scale real-world LLM conversation dataset, studying how people interact with large language models, LLMs, in real-world scenarios is increasingly important due to their widespread use in various applications. In this paper, we introduce LLM-Chat-1M, a large-scale dataset containing 1 million real-world conversations with 25 state-of-the-art LLMs. This dataset is collected from 210K unique IP addresses in the wild on our Vicuna demo and Chatbot Arena website. We offer an overview of the dataset's content, including its curation process, basic statistics, and topic distribution, highlighting its diversity, originality, and scale. We demonstrate its versatility through 4 use cases: developing content moderation models that perform similarly to GPT-4, building a safety benchmark, training instruction following models that perform similarly to Vicuna, and creating challenging benchmark questions. We believe that this dataset will serve as a valuable resource for understanding and advancing LLM capabilities. The dataset is publicly available at the project's website. LLM-Grounder, Open Vocabulary, 3D Visual Grounding with Large Language Model as an Agent. 3D visual grounding is a critical skill for household robots, enabling them to navigate, manipulate objects, and answer questions based on their environment. While existing approaches often rely on extensive labeled data or exhibit limitations in handling complex language queries, we propose LLM-Grounder, a novel zero-shot open vocabulary large language model (LLM) based 3D visual grounding pipeline. LLM-Grounder utilizes an LLM to decompose complex natural language queries into semantic constituents and employs a visual grounding tool, such as OpenScene or LARF, to identify objects in a 3D scene. The LLM then evaluates the spatial and common sense relations among the proposed objects to make a final grounding decision. Our method does not require any labeled training data and can generalize to novel 3D scenes and arbitrary text queries. We evaluate LLM-Grounder on the ScanRefer benchmark and demonstrate state-of-the-art zero-shot grounding accuracy. Our findings indicate that LLMs significantly improve the grounding capability, especially for complex language queries, making LLM-Grounder an effective approach for 3D vision language tasks in robotics. Videos and interactive demos can be found on the project's website. A paradigm shift in machine translation, boosting translation performance of large language models. Generative large language models, LLMs, have achieved remarkable advancements in various NLP tasks. However, these advances have not been reflected in the translation task, especially those with moderate model sizes, that is 7B or 13B parameters, which still lag behind conventional supervised encoder-decoder translation models. Previous studies have attempted to improve the translation capabilities of these moderate LLMs, but their gains have been limited. In this study, we propose a novel fine-tuning approach for LLMs that is specifically designed for the translation task, eliminating the need for the abundant parallel data that traditional translation models usually depend on. Our approach consists of two fine-tuning stages. Initial fine-tuning on monolingual data, followed by subsequent fine-tuning on a small set of high-quality parallel data. We introduce the LLM developed through this strategy as Advanced Language Model-Based Translator, ALMA. Based on Llama 2 as our underlying model, our results show that the model can achieve an average improvement of more than 12 BLU and 12 COMET over its zero-shot performance across 10 translation directions from the WMT21 2 directions and WMT22 8 directions test datasets. The performance is significantly better than all prior work and even superior to the NLLB 54B model and GPT-3. 5-text DaVinci 003 with only 7B or 13B parameters. This method establishes the foundation for a novel training paradigm in machine translation. MetaMath, bootstrap your own mathematical questions for large language models. Large language models, LLMs, have pushed the limits of natural language understanding and exhibited excellent problem-solving ability. Despite the great success, most existing open-source LLMs, for example Llama 2, are still far away from satisfactory for solving mathematical problems due to the complex reasoning procedures. To bridge this gap, we propose MetaMath, a fine-tuned language model that specializes in mathematical reasoning. Specifically, we start by bootstrapping mathematical questions by rewriting the question from multiple perspectives without extra knowledge, which results in a new dataset called MetaMath QA. Then we fine-tune the Llama 2 models on MetaMath QA. Experimental results on two popular benchmarks, GSM 8K and Math, for mathematical reasoning demonstrate that MetaMath outperforms a suite of open-source LLMs by a significant margin. Our MetaMath 7B model achieves 66.4% on GSM 8K and 19.4% on math, exceeding the state-of-the-art models of the same size by 11.5% and 8.7%. Particularly, MetaMath 70B achieves an accuracy of 82.3% on GSM 8K, slightly better than GPT-3 5 Turbo. We released the MetaMath QA dataset, the MetaMath models with different model sizes, and the training code for public use. BTLM3, B8K7B parameter performance in a 3B parameter model. We introduced the Bitensa language model called BTLM3B8K, a new state-of-the-art 3 billion parameter open-source language model. BTLM3B8K was trained on 627B tokens from the Slim Pajama dataset with a mixture of 2048 and 8192 context lengths. BTLM3B8K outperforms all existing 3B parameter models by 5.5% across downstream tasks. BTLM3B8K is even competitive with some 7B parameter models. Additionally, BTLM3B8K provides excellent long context performance, outperforming MPT7B8K and XGen7B8K on tasks up to 8192 context length. We trained the model on a cleaned and deduplicated Slim Pajama dataset, aggressively tuned the MuP hyperparameters and schedule, used alibi position embeddings, and adopted the Swiglu nonlinearity. On Hugging Face, the most popular models have 7B parameters, indicating that users prefer the quality-size ratio of 7B models. Compacting the 7B parameter model to one with 3B parameters with little performance impact is an important milestone. BTLM3B8K needs only 3 GB of memory with 4-bit precision and takes 2.5x less inference compute than 7B models, helping to open up access to a powerful language model on mobile and edge devices. BTLM3B8K is available under an Apache 2.0 license on Hugging Face, the project's website. Boolformer, symbolic regression of logic functions with transformers. In this work, we introduce Boolformer, the first transformer architecture trained to perform end-to-end symbolic regression of Boolean functions. First, we show that it can predict compact formulas for complex functions which were not seen during training when provided a clean truth table. Then, we demonstrate its ability to find approximate expressions when provided incomplete and noisy observations. We evaluate the Boolformer on a broad set of real-world binary classification data sets, demonstrating its potential as an interpretable alternative to classic machine learning methods. Finally, we apply it to the widespread task of modeling the dynamics of gene regulatory networks. Using a recent benchmark, we show that Boolformer is competitive with state-of-the-art genetic algorithms with a speed-up of several orders of magnitude. Our code and models are available publicly.